was very nice, honestly, and thank you very much. And again, as I mentioned earlier, the presentation, this session should be placed in the early morning, actually, because you have touched a very interesting point, and we're all suffering from this. And I think the coupling of the both presentations and the idea of digitalization and coupling it with the software and the whole idea of the DMAs and the approaches for whether it's down, top, and top-down approach, that's actually what we need. And my suggestion that maybe later after this, that you should contact the holding company and the subsidiary companies and stuff. Okay, thank you very much. And the last presentation, of course, but not the least, يعني he's العريس بتاع النهارده. 13 مهندس عمرو سعودي. مش عارف اقدمك بقى عمرو ولا لا ما اقدرش يعني he's more experienced in depression, mental social development. حقيقي يعني when it comes to desalination, the mind goes to Amr Seoudy. That's in brief يعني in the country. This guy has been there for a long time. Everyone is known to us and very knowledgeable, very enthusiastic, very helpful. Thank you, Amr, for everything. And I appreciate your presence.
Thank you for inviting.
You're going to give us today the artificial intelligence in water treatment industry performance optimization impact.
Presentation about artificial intelligence, desalination industry performance optimization impact. The outlines of the presentation, desalination industry challenges. We mentioned it in the first session, so I will skip some slides because already in the first panel discussion we introduced some of them. What is artificial intelligence? Little definition of artificial intelligence. Information technology and operation technology. What is the issue for them? Intelligent desalination system and simulation of RO, seawater RO system decision. It's a rare case. And experimental investigation for the existing seawater RO system, and then prediction of the performance under normal and abnormal conditions. And in a proposed chart, operation chart in case of working under different salinity and temperature, and then the conclusion. We talking in the morning about the challenges facing the desalination, about the production of the employees, the marine failure, environmental impact, the energy, the water cost, and the energy cost. Okay, because we're talking in the morning, so I will skip some slides. No. Okay, good. What is artificial intelligence? And artificial intelligence, there is a lot of definitions for the artificial intelligence, but what I like to prefer it is a simulation. The artificial intelligence is a simulation for the human being mind to have the advantage of from the people who have a lot of experience, the intelligent, a lot of experience, then they can pass away, and we have to get the advantage of what they have, the experience they have in their life. So it's a simulation and accumulation of the thinking and acting as a human being. We have two types of classification of the artificial intelligence, based on capabilities or based on the function of the artificial intelligence. And also I will try to go through these slides to go directly to the case we are talking about. And the material will be available on the website for the Congress. In the desalination, especially in the desalination system, we have, as we mentioned earlier, we have a lot of items, a lot of equipment, and each item, as I mentioned earlier, has its own government equation and its own performance. And the issue here is that we have an integrated system. I like normally to introduce the desalination system like the laptop. The laptop or the computer have a lot of items, the motherboard, the hard disk, a lot of items. I don't want the process, I don't want to forget. So we have a lot of each item has its own performance. And the challenge is that to have all of these items to operate together, to be integrated and compatible. And I think we have the same issue in the desalination system. The advantage in the laptop and the computer is that it's all of them based on the electronic and electricity and so on. But in the desalination, we have mechanical, electric, chemicals, a lot of different bases, so this is another challenge. This is an example that we have information technology. We can collect all the data. We have a lot of instrumentation in the simulation system. We have this example in human Sura. Next. In human Sura as example, it's a real plant in operation for 2 years now. We have about 120 instruments. We have 150 control valves. We have 65 equipment. We have about a total of 300 equipment. And we have a lot of digital input, digital output, analog input, analog outputs. And we have all of this data. So it's good. It's good that we have the data. And so what? We have to deal with this data. We have to make analysis. We have the advantage of all of this data to make the optimization for the performance of the system. So here we have a gap between the operational technology and the information technology. So we need to make a bridge. We need to connect it together. I think artificial intelligence can do this. Maybe not totally in this time, but maybe in the future. So we have to find a link because we have a huge number of data for the SCADA system, the system, whatever. And then so what we can do? Just in the existing software, we can make some orders, can stop, you can make alarm, but in the future, I think it will be controlled totally the plant and take a decisions, not only stop or give alarm and give the decision for the operator and so on. Because it needs a lot of accumulation of experience. And every day we have more technologies, more updates, and less skilled people. Less skills. Next. Okay, next. Artificial intelligence and the relation between artificial intelligence, machine learning, deep learning, and what we introduced today is a simulation. What's the relation between the artificial intelligence and simulation? The simulation data will improve artificial intelligence and machine learning because it make it. We don't need to waiting for a long time to know what's happening and what we'll do. But by simulation, we can make a simulation for the existing system and expect it what will happen, and so we can minimize the time to reach to the optimum, the optimum and the best operation points for the installation system. And also the artificial intelligence and machine learning will improve the simulation. It will be like a cycle to improve it. Each item will improve as others. Next. Okay. Here we'll introduce a real case for a destination plant, small unit, done, and make a simulation for this software simulation, and then make validation for this software for their case. This is a conventional system. We decide to go to traditional system without any recovery system, just booster pump, filters, and high pressure pump, and RO membrane. To make it easy. For each item, we're starting to define each governmental characteristic equation for each item here for the centrifugal pump, and we define the curve, the specific curve for this pump, and then the equation for the multimedia filter and the carbon filter. Of course, carbon filters now is not commonly used, but it is our case. And this equation governs the characteristic equation for each item. Next. And here in our case, we have high pressure pump with the type of reciprocating pump, positive displacement pump. Okay, and this equation, characteristic equations, and the volumetric velocities, and so on. And then we go deeply for each item in the pump, the delivery valve, the suction valve, the piston chamber, the piston itself, because this is the motion, of course, totally different than the centrifugal pump. We have a centrifugal pump in the booster pump, so we have the good thing, we have two different types of pump in this case. Okay, it's the same for the valves, okay? And this is a simulation model. We make it in Simulink, MATLAB Simulink. Okay, next. We just showing, and this we have here a case for the positive displacement pump. we have to use pulsator or accumulator to avoid the pulsation, the effect of the pulsation of the piston in the other system. So also we find the equation and the characteristic equation and for the accumulator for the valve and so on. Next. And this is the simulation model for the using MATLAB for this item. Next. And now this is the membrane. It's interesting. In this part, this equation for Q product for the membrane is well known for all the people in the field. And here that we try to explain how this equation can work and how it's coming from by this chart. We use a section in the membrane and make a distribution for the pressure and osmotic pressure and other figures. We can find also the distribution of the flow through the membrane element. Next. Next. This is the feed flow. Next. Next. This is the equation of the membrane itself. Okay. Next. And this is the same link model. And this is the reject header or the prime header. Okay. Next. 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 After that, we have this is a real planet. We make experimental investigation to validate this software, this Simulink software, and we make a validation using the data acquisition system. And this is a test rig. Next. And we started to measure each item with pressure transmitter, pressure flow meter transmitter, and all the other equipment, speed transmitter, and so on. And we start to validate each item and define the equation with the specific constant for each item or each equipment. And this is the high pressure pump. Next. And these figures, these charts for the membrane cell with different condition. And here, this chart showing the pressure fluctuation for the high pressure pump for in different operation condition. And here we start to validate the two colors, the red and blue, comparison between the theoretical and the experimental measurement investigation, and then we start to have like a footprint, like a fingerprint, like a fingerprint for this unit. Next. And now we're starting to assume, to expect that abnormal condition, because at the end we have software. What is the advantage? I have a simulation software. What is the advantage? Okay, it's good to make expectation for some what will happen and so on. So we start to make some abnormal condition in the operation in force. So we start to make stick for one valve, do this, to make like a fingerprint for each case. If we have, because and we can show next. Okay. Here we have piston pump with a charged accumulator while one delivery valve is sticking. We assume that this is pump with 5 piston pump. We assume that this one of the valve is sticking for any reason, some material, something. So the curve for the flow will be like this, and the curve for the pressure will be like this. It's almost mostly because of the accumulator, but the flow is affected because when the valve is open, so these chambers looking like it's not in the operation. Next. And this was an empty accumulator while one delivery valve is sticking. With empty accumulator, we can see to the right that the fluctuation of the pressure is starting to. Next. We assume 9 cases and make simulation for this 9 cases in real case and make it like footprint. So in the software, we make it as a reference. When the system can measure this fluctuation, so it's expected that the valve is taking and the accumulator is not working, and so on. Of course, we make only 9 cases, but these cases will help when we integrate it with artificial intelligence system or software. It can help to minimize the time to have many more cases and abnormal conditions. These some figures showing the failures, and even also we can measure either by the chart or by the figures. With these numbers, we can expect what's the problem. Next. Next, one of the advantages of this software is that we're starting to assume to give the operator a chart, like a map. If you have the water salinity, say 30,000 ppm, and different feed flow, and different water temperature from 18 up to 26, this is the area you can, it's better to work in this area. So it's like the working area for this specific planet or for this specific unit. So this software is not common, it had to be done case by case. Because all the constant, maybe the equation is common, but the constant for each planet will be different for the other. Next. Here we change the salinity. Next. Next. Conclusion. I think conclusion is clear. If we have to go to in destination system, especially with RO system, reverse osmosis, with all of these details, it's better to have a simulation integrated with artificial intelligence, and we can say most probably, or I don't like to say 100%, it will affect and optimize the operation and the performance of the destination system. And thank you.